Welcome back, everyone. Today, we're diving into a super practical explainer. If you're building Captcha automation in Node.js, you've probably already figured out that the real challenge isn't actually just getting a single solved token, right? The true test is keeping that entire workflow stable when it's running completely unattended. We're talking about running it in a background queue, a cron job, a CI flow, or some internal worker system. Because a simple Captcha script might work beautifully for a quick little demo, but man, it can break so fast in production if things like polling, retries, sessions, and monitoring aren't handled correctly. So settle in, because we're going to look exactly at how to build a highly reliable, observable Captcha queue using BullMQ.
Okay, let's just dive right into the core problem here, the production trap. It's a trap that catches, honestly, almost every automation developer at some point. You write a simple script, you run it locally, and boom, it perfectly solves the Captcha and submits your form. It works that one time. But here's the thing. A quick demo script is synchronous. It assumes the happy path. When you push that exact same code to a production pipeline where it runs entirely unattended, the game changes. Networks hiccup, API response times fluctuate wildly, and suddenly your script just hangs forever, or worse, crashes your entire CI pipeline. In a real production environment, you absolutely need predictable latency, clean failure handling, safe retries, and really clear monitoring.
So, here's our roadmap for today. 1. The production trap. 2. The BullMQ paradigm. 3. The practical checklist. 4. Mistakes to avoid. And 5. FAQs and takeaway. Section 1. The production trap. Why simple scripts fail unattended. So to stop your scripts from hanging, you really need an architectural pivot. Enter BullMQ. It's this incredibly powerful background queue system for Node.js, and it's a total game changer. It lets you move the entire Captcha solving process out of that fragile synchronous script and right into a resilient background queue. Inside this queue, every single task can be individually processed, safely retried, given a strict timeout, logged, and properly measured. You basically stop treating the solve as a blocking script and start treating it as an asynchronous background job. Section 2. The practical checklist. 6 steps to production readiness. All right, steps 1 and 2 are all about data discipline. Step 1. Capture only the exact inputs the Captcha solver actually needs. We're talking about things like the site key, the page URL, the action value, the Captcha type, maybe some optional proxy data. Please do not scrape and store unnecessary page data. If you capture massive HTML blobs, you're just creating incredibly confusing debugging paths for yourself later on. Keep it lean. Now, step 2. When you submit the task to your API, you've got to treat errors seriously. If the API response is literally anything other than a clean success, log that full response internally and stop the worker job right there. Do not let your queue just continue grinding away with fundamentally bad data. Step 3 is your polling strategy. Once you submit a task, you can't just spam the API asking if it's done yet. Overpolling adds noise, but underpolling just unnecessarily slows your whole pipeline down. The sweet spot here is a highly controlled polling strategy. Submit the task, explicitly wait 15 seconds before you even make your first poll, and then poll every 5 seconds after that. And crucially, you absolutely must establish a hard timeout limit. Stopping the job at around 120 seconds ensures that if something goes completely off the rails, your queue worker is freed up for the next task instead of just being locked infinitely.
Step 4. Listen closely, because this is absolutely critical. Apply the solved token in the exact same session that triggered the Captcha. Seriously, mismatched sessions are easily the #1 reason a perfectly solved token gets rejected post-solve. The exact same browser context, HTTP client, or cookie jar that triggered the initial challenge must be the exact same one that continues the flow and submits the token. If it's solved in session A and submitted in session B, it's almost guaranteed to fail.
Step 5 covers your retry budget. Look, BullMQ makes it super easy to retry failed jobs, and retries are awesome for temporary network hiccups. But unlimited retries, they just hide real defects in your code and rapidly burn through your API budget. It's a bad idea. You need to cap your retries, usually at around 3 attempts, and use exponential backoff. That way, you're waiting a bit longer between each try and you aren't just hammering the server. And of course, log every final terminal failure so your engineering team can actually investigate what went wrong. Step 6 makes it really vital distinction: solver success versus workflow success. Getting a solved Captcha token does not automatically mean your final form submission, login, or checkout actually succeeded. Think about it. The solver API might give you a valid token, which means you have a 100% solver success rate, but if you apply it in the wrong session, your downstream acceptance rate drops to 0. You have to track these two metrics completely separately.
Measure your solve latency, your retry count, your timeout rate, and your downstream acceptance. You need to know your true cost per accepted solve. Measure both, always.
Section 3. Mistakes to avoid. Common pitfalls in automation.
We've definitely touched on some of these, but let's officially formalize these red flags. First, do not just measure solve jobs. Like we just talked about, if you aren't measuring whether the final workflow actually accepted the token, you're flying blind. Second, never ever retry bad parameters forever. If your site key or your API key is just wrong, running it 50 times in a row won't magically fix it. It's just literally throwing money away. Third, do not lose session context between the trigger and the final submission. And finally, never run a queued job without a strict timeout limit. Every single job in BullMQ needs a definitive, clear-cut stopping point. No exceptions.
Section 4. FAQs and takeaway. Architectural questions. Now you might be wondering, with all the different tools available in the Node.js ecosystem, why specifically use BullMQ for this kind of workflow?
Well, the core answer is that Captcha solving is inherently asynchronous and honestly unpredictable. Sometimes a solve takes 8 seconds, sometimes it takes 45 seconds. Queues are designed to naturally tame that unpredictability. BullMQ specifically gives you that much-needed dashboard visibility, the built-in safety for exponential back-off retries, and incredibly clean failure handling that standard Node.js promises just don't give you out of the box. Here's another really common anxiety I hear from developers. What happens if the target website updates its security and the Captcha type suddenly changes? Does the whole pipeline just break?
The beauty of setting it up this way is what we call flexible task construction. If you design your queue properly, the actual API request going to the solver is just a payload of data, right? So if the Captcha family changes, you just update the task type in your payload. That's it. Your entire BullMQ submit, wait, pull, and timeout loop, it remains completely intact. You don't have to rewrite your whole operational workflow just because some front-end security tool got an update.
Okay, before we wrap this up, I do need to relay a very clear safety note directly from the source material. The architecture we've been discussing today is incredibly powerful. And exactly because it's so powerful, it must only be used in environments where you have explicit authorization. We are talking about applications you actually own, systems operated for a client who has authorized the integration, or environments where you have a clear contractual data collection agreement. This is all about building reliable, authorized engineering pipelines.
And that brings us to our final takeaway. Please, do not treat this process as just some one-off script. Treat it like the true operational workflow it is. Give it queue control, session safety, retry limits, and real downstream monitoring. If you work with Node.js automation, internal queues, or any technical workflows, really save this 6-step checklist. Review it before you ship your next BullMQ integration. I promise it's going to save you so much debugging time. Which actually leaves me with a question for you to think about. How many fragile, unattended scripts are hiding in your infrastructure right now, just waiting to break?